So I kind of feel like Unit 3, all of it, is a little bit of a break from Unit 2 because it's much easier. And this particular lesson is a break even from what we were doing in the rest of Unit 3. Not sure why it's stuck in the middle like this, but hopefully we'll figure it out eventually. Your first vocabulary word or phrase is roster form, and that is a list of all elements in a set. Notice that there are brackets on either side, and it's got to be that kind of bracket. You'll see that I had a little bit of trouble writing it. I don't know, I think I wanted to turn it into a quarter rest or something. But anyway, it's just a list of the things in the set. These dots mean that the pattern continues. So in other words, this set has got even numbers in it. Your next vocabulary word, set builder notation, which is a rule that shows you how to build the set. So we've still got the brackets on either side of it, but there's x and this line. X is a multiple of 2. So the way you read this sounds kind of like, funky math speak again. The set of all numbers x, where x is a multiple of 2. So these two things are the same set. It's just this one is giving you the exact elements, and this one is giving you the rule. This one's called roster form. This one's called set builder notation. Problem number 1 on page 194 gives you a little bit of practice with this. So here, your two examples, the same exact set on either side. This one is roster form, this one is set builder notation. And they would like you to try it for yourself in Got It number 1 on the top of 195. You guys go ahead, figure it out, get it written in your book. I need to go refill my tea. It's cold and mostly empty. Okay, my tea is now hot enough to burn my mouth, so now I'm going to go back to filming and let it cool down again. Got It number 1 gives you the directions and is the set of even natural numbers that are less than or equal to 12. I know you were hoping you wouldn't ever have to remember what a natural number was again. So much for that. How do you write n in roster form and in set builder notation? And here you go. In roster form, I'm still having trouble trying to make this a quarter rest or something. Those are all the natural even numbers less than or equal to 12. But also this way. The set x, where x is even, natural, and x is less than or equal to 12. There you go. Grr, problem 2 is another multiple choice. The point here is you've got a couple of steps. How do you write the solution of that? Well, you know what to do to start with. First you simplify it, x is greater than or equal to -2, but you are not done because they asked for your answer in set builder notation, which means after you figure out this, you must take this step and write it out that way. The set x where x is greater than or equal to -2. The answer is, I don't care about that. Multiple choice makes me crazy. All right, got it. In set builder notation, how do you write the solutions of that? This is also going to be a 2-step problem. First you have to simplify it, then you have to put it in set builder notation. You give it a shot. Here is the problem they gave us. And I started to simplify. And look at what I forgot to do. Divided by -4, and I forgot to flip the sign. So I marked that right there. And you're not done. You need to put this in set builder notation. And I made 2 mistakes down here because not only did I forget to flip the sign, but then I decided we were using x's instead of n's. What a mess. So for whatever reason, I was so excited at the beginning of this chapter that I forgot to get all the vocab at the beginning. So we have a little more vocab right now. Next thing I want you to know, an empty set is also called a null set, and it can be symbolized by 0 with a line through it, or empty brackets. Hey, look, I finally got my bracket right. An empty set is a set with no elements. Makes sense. Next vocabulary word, a universal set. The largest set you are using. So for example, if you go back to the set that we used before, whole numbers, natural numbers, real numbers, rational numbers, irrational numbers, real numbers was our universal set. That was the largest set that everything was a part of. Next word, the complement of a set is all elements of the universal set that are not in the set you are talking about. For example, remember this? If we are talking about the set of students, then this red set, people whose job it is to be at UFS every day, and the UFS community, these elements here are complements of the student set. If we are talking about this red set, people whose job it is to be at UFS every day, it includes Nancy, Bob, Jackie, and all of the students. The people out here are the complement of this set. So you're talking about this set. What is outside of this set is the complement. Then I have one important symbol that you need to recognize and be able to draw, the subset symbol. Now, this should look more like a sideways U. There we go, and less like a C. The subset symbol is that with a line under it. So, right here means A is a subset of B. But what is a subset, you say? Aren't you glad I didn't make you write it as a vocabulary word? If every element of A is also an element of B, A is a subset of B. For example, if you have this set for B and this set for A is a subset because every element -1, 0, 2 is also in that set. And here's the symbol. A is a subset of B. Then they go on talking about empty set, and problem 3 involves finding subsets. What are all of the subsets of that set? Well, the empty set, the 3 sets that have only one element, the 3 subsets that have 2 elements, and the full set is also always considered a subset. Okay, so there are 8 subsets of that one set. Try it out for yourself with got it, number 3, letter A. What are the subsets of those 2 sets? You go ahead. I'll wait. So your list of subsets for set P ought to look like this. There are 1, 2, 3, 4 of them. Your list of subsets for set S ought to be quite a bit longer. I guess I better zoom out. There we go. Almost all of them. Okay. 1, 2, 3, 4, 5, 6, 7, 8 subsets of set S. And for letter B, this was a thinking question, not a writing it out question. So problem 3, letter B, gives you these 2 sets. I'm going to make those lines a little longer so that it is more clear that this is the set builder notation. The set where x is less than -3 and the set where x is less than or equal to 0. The question is A a subset of B? What do you think about that? And you're thinking, and you realize, why, yes, A is a subset of B because all of these numbers are also in that set. Because you're smart, you figured that out. Moving on to problem 4. On the top of page 196, this is where they have their definitions of universal set and the complement of a set. So they have different explanations here. Set A is a subset of U. The complement of set A is shaded, and they have the complement of set A labeled A prime. That's one way to do it. So, problem 4, finding the complement of a set. For some of you, this is going to be fascinating because it involves chess, and for some of you, it's going to make you feel like this. I know, because chess drives you nuts. They are giving you the universal set, the whole set of king, queen, bishop, knight, rook, pawn. And set A is the pieces that can move side to side. I'm going to let you read through that because my talking is not going to make it any more clear. I'm going to move on to got it number 4. Universal set is months of the year. That's something we can all handle. And set A is the months with exactly 31 days. What is the complement of A? And write your answer in roster form. Phew, not set builder notation. So while you guys try and remember the rhyme, how's it go? 30 days has September, April, June, and November. All the rest have, that's right, 31. except for February. And you go back and play that again until you get that list down, and then we'll check in our notebooks. So here's our universal set, all of the months. Here is our set A, all the months that have exactly 31 days. What is our complement? All those other months. 30 days has September, April, June, and November. And February doesn't have 31 either. And the other way to label this is A prime. The complement of set A can be labeled A prime. That's all they want. It's really that simple. A simple lesson calls for simple extra practice. So lesson check, page 197, and then we'll check it in class tomorrow.